Good morning, children. How are you? How is your studies going on? That means watching the videos. Are you watching, children? Let me see how much. Is it? Yes. Welcome back to our session. What's our topic is going on? It is work and energy. So, in the last classes we have seen about what is the kinetic energy, what is potential energy. Regarding that, we have solved few problems, is it? And I have given the home task also. Have you solved, children? Okay, very good. So today's our topic is law of conservation of energy. Law of conservation of energy. The law of conservation of energy states that energy can neither be created nor be destroyed. We cannot create any energy, or there is no capacity, no rule to destroy it. Then what we can do? Although it may be transformed from one form to another. What we can do? We can transform from one form to the another. This is called as the law of conservation of energy. Very important, children. Energy can neither be created nor be destroyed, although it may be transformed from one form to another form. So, examples: in a loudspeaker, electrical energy is converted into sound energy. Here, what it is happening? It is transforming one form to electrical energy to sound energy. Then, in a generator, mechanical energy is converted into heat energy and as well as light energy. So, these are the examples for our law of conservation of energy. So, let me consider with a small example. So, that is, think that object mass m and it is falling through a particular height. Mass m, height h. So, what will be its potential and kinetic energy? It will be 0 because they are in the still rest position. That means it is because its velocity will be the 0. Then the total energy of that object is, what is the formula we have learned that? mgh. mgh. Then it is going to fall. The potential energy, it is also going to change. As it falls, the potential energy will change into the kinetic energy. So, for example, a fruit is there on a tree. So, which position? That means which energy it is having? It is potential energy. When it is falling, it will be having the kinetic energy. So, if v is the velocity of the object of a given some instant, then the kinetic energy would be the half mv square. This one also we have learned, half mv square. So, yeah, the velocity will be the v. So, what's the formula here? Half mv square. So, if the object falls continuous, the potential energy will be decreases and the kinetic energy will be increases. If the potential energy decreases, then the kinetic energy will be increases. Then, when the object is about to reach the ground, down, then how we can calculate the height? Height h will be the 0. So, and the v will be the highest. If the height, then it is reaching to the ground, it is 0 means the v value will be the highest. So, therefore, the kinetic energy would be the largest and the potential energy will be the least. So, however, the sum of the potential energy and the kinetic energy of the object would be the same at all the points. So, for that, we can say potential energy plus kinetic energy. What is potential energy? The formula which we are going to take. Potential energy plus kinetic energy will use for us. It's the same. That means it's the constant. Is it? Then What is the formula for the potential energy? It is nothing but mgh plus half mv square is equals to constant. What is that constant? So, potential energy and as well as the kinetic energy is nothing but our mechanical energy. Understood, children? Yes. So, carry on this one. So, today's class we have learnt about the law of conservation of energy. So, by this let me end up the session and tomorrow's class with the new topic. Let me meet you. Okay? Thank you, children.
Laws of conservation of energy. We now know that the form of energy can be changed from one form to another. Whenever energy gets transformed, the total energy remains unchanged. This is the law of conservation of energy. According to this law, energy can only be converted from one form to another. It can neither be created nor be destroyed. The total energy before and after the transformation remains the same. Let us consider a simple example. Let an object of mass m be made to fall freely from a height h. At the start, the potential energy is mgh and kinetic energy is 0. Why is the kinetic energy 0? It is 0 because its velocity is 0. The total energy of the object is thus mgh. As it falls, its potential energy will change into kinetic energy. If v is the velocity of the object at a given instant, the kinetic energy would be 1 upon 2 mv square. As the fall of the object continues, the potential energy would decrease while the kinetic energy would increase. When the object is about to reach the ground, h is equal to 0 and v will be the highest. Therefore, the kinetic energy would be the largest and potential energy the least. However, the sum of the potential energy and kinetic energy of the object would be the same at all points. That is, potential energy plus kinetic energy is equal to constant, or mgh plus 1 upon 2 mv square is equal to constant. The sum of kinetic energy and potential energy of an object is its total mechanical energy. We find that during the free fall of the object, the decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. There is thus a continual transformation of gravitational potential energy into kinetic energy.